In this video, we have a look at the concept of perpetuities. Now that's basically, in a financial sense, a payment which is ongoing. Someone might set up a scholarship or a benefit so they can pay out a regular amount of money over and over again, ongoing into the future. Let's have a look at how this basic idea works and how it can be sustained. Let's assume someone invests some money, represented by the rectangle on the left-hand side of this diagram. Now over time it will accumulate interest. Now if we want to set up a perpetuity, what we can do is take that interest and transfer it across to our perpetuity. Now that means that we've still got the original amount of money that we had in the first place. So we can repeat this process. We can again grow some interest, take that interest and transfer it across to our perpetuity. And again the process repeats. So let's have a look at a question that applies this process. It's suggested that you pause here and read the question, and then we'll check some of the key words. Now the key part of the question is we are setting up a perpetual scholarship. So that means we want that $10,000 per year to be paid ongoing into the future. We can see that we've got an account paying 5% interest compounded annually, and we need to know how much do we have to invest to ensure we can sustain this perpetual scholarship of $10,000 per year. Let's first of all have a look at the question from the point of view of the interest. We saw there was 5% interest. So what we know is that each year we get the amount of money back, in other words 1 multiplied by itself, plus the extra money, which is the 5% of the amount that we invested, or in the case of a decimal, 0.05. We can abbreviate that algebraically so we can use letter A to represent the amount. What we'll then do is we'll look at the interest calculation, because remember the interest is the extra amount which pays the perpetuity. So 1 multiplied by the original amount, or 1A, gives us the original amount back. 0.05A is the interest, and it's that interest that we need to equal $10,000, which is our scholarship. So let's put 0.05 multiplied by A equal to $10,000. So that's the extra amount that we're going to pay each year. And we're trying to solve this problem to work out what the value of A is. So that means we need to divide both sides by 0.05. So the amount of money is 10,000 divided by 0.05, and that comes to $200,000. So if we're to sustain a prize of $10,000, of course assuming the interest rate is maintained at 5%, we have to invest $200,000. Let's have a look at another problem now where we've changed one of the small conditions on the previous question. So we've only made one small change to the previous problem, and that is that we're generating the interest on a monthly basis, which more likely reflects a real situation. Most scholarships will be set up on an annual basis, whereas interest may be calculated quarterly, monthly, or daily in various accounts. So let's have a look at how we go through this problem, keeping in mind we're still looking at the extra money to be our scholarship. So 5% per year becomes 5/12% per month. Now when we rewrite this into our formula for the total amount of money leading to the scholarship, let's keep in mind that the interest will be calculated 12 times, in other words each month of the year, prior to the scholarship being awarded. So our expression for the amount of money in the account at the end of 1 year will be as follows. First of all, you'll notice in the bracket we're multiplying by 1. That's because the amount of money that we get will receive back with a little bit extra. That's the numbers expressed in orange. So 5% is 5/100, and also we divide by 12 because that 5% is per annum. So we need to divide by 12 to indicate it's a monthly calculation. The reason why the brackets are to the power 12 is because we repeat that calculation 12 times prior to the scholarship being awarded. We'll abbreviate that by using letter A for the amount. So we'll express that as being the total amount, which is the amount there in brackets to the power 12 multiplied by A, minus the A, that gives us the interest, in other words the extra money, and that will equal $10,000, which is our scholarship. What we'll then do is we'll factorize the A out of that expression on the left hand side, so we end up with a number in the red brackets. We're going to then divide 10,000 by the amount in the red bracket, and we end up with $195,457.96. Now that's marginally less than the $200,000 which we needed if the interest was calculated annually. And that makes sense because if our amount has got an interest calculation occurring monthly, we'd expect to accumulate more money prior to our scholarship being awarded at the end of a year.